Hi, welcome back to part 2 of the Leetcode Solver series. In the previous challenge, we explored how the architecture looks like, and we also shown how this project is really consisting of two parts. The first part is the Streamlit application, which is your prototype app, both serving as your front end as well as your back end. And we also explored the second part, which is how we interface with GPT-3 via an API call. And to be specific, we will see how we can use OpenAI's library. And the OpenAI library consists of objects and functions that will allow us to make an API call to GPT-3 service. So with that, let's get started. So for this video, we'll be exploring how the GPT-3 API works. And this would give us a better idea of how we should interface with GPT-3 and giving us in the next video how we should frame our Streamlit application to be compatible with GPT-3's API. So now, to better understand how GPT-3 works, typically the rule of thumb would be to explore their API reference over here. So to be specific, over here. So if you have not signed up, I would highly recommend you to sign up on their page over here. And this will give you an API key along with some free credits to try out their model. And as we explored in the previous video, we were using the Code DaVinci model, which is available as of July 24th, 2022. And these Codex models, which are in beta, are also optimized for exactly the project that we are using over here. And this Codex model is trained on a huge corpus of code available on GitHub. And the best part is it's actually free because of the beta. So if you are happening to watch this close to the launch of this video, then I would highly recommend you to sign up for the beta as well. So once you get the beta, you can start to see the examples inside this URL over here. And what you have here are a couple of examples that are curated by the brilliant people at OpenAI. And over here, what we have is a very simple example of question and answer. And they are also nice to show you exactly how you can experiment with this with just a few lines of code. So with that, let's start exploring that. So let's copy this code over here and let's paste it inside a new project inside our PyCharm. So what I have over here is a simple folder that doesn't contain anything at all. I'll just be creating a new file called main.py, and this would be the main access point for our application later. But for now, I'll be using it as a test script to understand how OpenAI works. So I'll be going through this line by line. So what we're doing here is, on the first line, we're importing the OS library to get access to some helper functions to get environment variables from. And it's usually a good rule of thumb to put your API keys as environment variables. And that is so that you can not expose those keys as string variables inside your script. And this is typically a good security practice, so that these API keys live only on your local machine and your code stays clean of having any confidential API keys which others can steal from you. On line 2, we imported the OpenAI library, which we haven't installed yet, so we cannot inspect it. So let me just deactivate this. I was using this for a demo just now. And on line 4, we are setting the API key for OpenAI so that we can use it in the subsequent parts of the code. So on line 6, we are creating a completion object. And this completion object is part of the OpenAI library and consists of many helper methods to give a prompt to OpenAI, and OpenAI will return back a completion from this method over here. So for now, as you can see, we are having trouble inspecting this. So let's install the libraries we need to introspect the OpenAI library. What I'm going to do here is I'm going to create a new file called requirements.txt. And inside this file over here, I'm just going to put in OpenAI. And notice in this case, I'm not specifying the version because I'm not sure exactly what version is available at this point of time. So before we do that, I'll be creating a virtual environment. Think of it as a black box that contains all the dependencies we need for this project. So there's a few ways you could have done that. You could have used a virtual environment and give this a name of VM and pass in the path to your Python 3.9 interpreter like this. But because I want my PyCharm project to also use the same virtual environment, I'm just going to call it and create the virtual environment from PyCharm instead. So what I did just now was select this button over here and go under interpreter settings, select this cog over here and add a new Python interpreter. So I'm going to call the virtual environment VM followed by underscore Leetcode. I'm going to press OK. And just like this, we have created our virtual environment in our project over here, as hinted by this folder over here. I'm going to enter this virtual environment by source VM bin activate. And now you can see that your terminal is currently targeting this virtual environment. Do pip3 freeze to check your dependencies in your virtual environment. And as you can see, it's empty. And that's understandable because we just created it. So now we can finally install the requirements into this virtual environment that we have over here. And what I'm going to do is I'm going to use pip3 Python package installer to install all dependencies inside this requirements.txt file. So I'm going to run this, and this is going to start downloading the OpenAI library. Notice from the logs that they specified the version of OpenAI is 0.2.0. And what I'm going to do is I'm going to do a solid and specify the version of OpenAI so that in the future, subsequent software engineers that are staring at this repository can use the exact same version that I was using when I was developing this application. So what I'm going to do right now is to initialize source control. I'm going to use git init to initialize a local source control. And if you do git branch, you can see that we're currently on, actually we're on master, but let me just check out to master. Okay, and we're on the master branch. You cannot see it because we don't have any commits. And if you type git log, you can see that there's no commits yet. So now if we select this and let's do git status, we can see that we have two untracked files, main.py as well as requirements.txt. I'm going to add requirements.txt into my staging area using git add followed by the file path. And I'm going to use git status to check the current status of my staging area. And as you can see, the requirements file is currently in the staging area. I'm going to commit this, git commit followed by the commit message. I'm going to specify this as add requirements. And the commit message will be add OpenAI as requirements. So this commit will just contain one change, which is the requirements.txt file changes. So after committing it, you can see that we have just source control the requirements file. If we do git log, we can see that we have added a commit to source control this requirements text file. So if you do git status, you can see that we have not committed main.py yet. So I will withhold from committing this file first because we're not done with this file. But at this stage, we have installed OpenAI. So what this means is if you hover your cursor over the OpenAI code and you do Command B, you can inspect the code from the OpenAI library. And what you see over here is a simple blueprint for an object of type completion from the OpenAI library. And this completion object is responsible for interfacing with OpenAI. So to be specific, they're GPT-3 engine. So now that we have set our OpenAI key, I'm going to set an empty string for the default. Before we started this project, I took the chance to save my OpenAI API key as an environment variable. And I'm just going to use the environment variable name for this project. So let me call this OpenAI shipit parrot key. This name of this environment variable is totally up to you to decide. But if you wish to set it, if you're unsure on how to set it, just to refresh our watchers who are setting this for the first time, you can use Vim, a text editor, and run this command on your terminal. I'll not be doing it because I'll be exposing my API keys otherwise. But in your file, do export followed by the key that you want. So in this case, if I want OpenAI SIP key, then I'll be passing in this line inside your bash profile. And what you have here surrounding between your single quotes is your OpenAI key that you get from OpenAI. So once you're done, you should be able to run this script yourself. So I'll also be abstracting out the completion object of type completion to be equals to I guess I'll just do from OpenAI import completion. Yeah. So this would be completion like this. And the reason I'm abstracting this is so that I can call create on this completion object many times. If I had done this instead, then I would be unable to reuse this same completion object that we just instantiated. So we are going to instantiate this completion object once instead and reuse that for multiple calls on the create method over here. So as you can see, if we command B on create, OpenAI is also very nice to provide us like a reference to the API, as well as explaining to us exactly what this method does. And in this case, they are basically saying this method takes in a prompt and instruction from the model and give you back the completion, which is the output from the model. So let's take the chance to copy this API reference and let's visit that instead. So let's check out the completion API. And as you can see, OpenAI is really nice to explain exactly what are each of the parameters to this function is doing. So for this project, I'll be explaining only the parameters that you'll be using. The first is the model. The model which is you're using, in this case, we're using Code DaVinci 002, which is the beta model that we're using. And the prompt is the instructions that you pass to it. In this case, the instructions is this whole chunk over here. Give a Python solution for the Leetcode question below all the way until line 46. Lines 47 onwards was what was given back to us when we click the submit button over here. And that is the completion, but I'll be going through that in a little bit. So the suffix, not important, so I'll be skipping that, but that is pretty much the suffix that is added into the completion. The max tokens over here is an integer, and it defaults to 16 tokens. You can think of a token as a word. It's not exactly a word really, but I'll leave that to another video. But the maximum tokens over here indicates the maximum number of tokens or words that you can get from the completion. And as you can see for our task, we are making the model give us back a long snippet of code. So 16 tokens is definitely not enough. So we'll be setting this max tokens to a higher number, such as 1000. Temperature, we won't be touching it here, but the temperature number is a float from 0 to 1. And the higher the temperature, the more risk the model is going to take. So it will be more spicy and more creative. So top P, in this case, is an alternative with temperature. And this has an opposite effect of temperature, but basically top P means top probability. So in this case, 0.1 means the token comprises the top 10% probability. So in other words, it will only choose like the tokens which are like at least 10% probable or not. But this is not important for us. I guess this would be more useful for subsequent projects. N controls number of completions that we have. Let's just default that to 1. Not very important. I guess we don't have to discuss log props yet. Stop tokens. So the stop token over here is used to indicate the end completion token. So what is the token that it should use to understand whether if that's the end of the completion? We won't be touching this for now, so that's fine. So yes, that's pretty much it. This is pretty much all the parameters we'll be using. So if you feel that you didn't catch much of what I said, it's totally fine. I'll be dedicating another video to go a little deeper into exactly how GPT-3 behaves. So for now, let's go back here and let's start making this work with a simple Leetcode question. So we have let's set this to the same model as what we used. And in this case, we're using Code DaVinci 002. Let's change this to Code DaVinci 002. Let's define a prompt. This prompt will be a multi-line string. And let's copy the whole prompt that we used just now over here. And notice that in this case, the prompt that we have consists of a Leetcode question. So I'll be extracting the Leetcode question into a multi-line string as well. I'll be copying this details about the question into a separate variable. So let me just copy this. And I'll be pasting it here. And I'll be using f-string formatting to place this Leetcode question into the prompt. So like this. So that's pretty much it. Then hopefully, if the model sees the Python solution, they will know that it is supposed to generate the completion right after this signposting over here. So let's paste this prompt that we have as a parameter over here. So prompt equals to prompt. I'll be removing temperature, top P, frequency, presence penalty, and the stop token as well. We do not need that. The only parameter that we need to edit is max tokens. In this case, 100 is definitely not enough. The default 16 is not enough. So I'll be setting the maximum tokens to 1000. So the reason being is that I would expect our code to be approximately less than 1000 words. So the response in this case is, let's check. At this point of time, we are not sure what the output of response is. So let's print out the response together with the type of the response. So looks great. We set our API key, we create the completion object, we formatted our Leetcode question in the prompt correctly, and we passed the prompt to the completion object create function, and now we got back a response. So let's try running this with Python 3 main.py. Okay, this would take some time. Let's see if this works. Okay. Prompt 02. Let's see. Okay, we got back the response. And we can see that the response is really of type OpenAI object. So this is a new object that we have never seen before. But if you are unsure how it behaves, what I like to do is to assign the object that I'm getting back as a type hint. And I would just take advantage of the import suggestion from PyCharm. And if you do Command B on this class, we'll see that this class extends from dictionary. So what this means is that even though it is an object of a custom type, you can access this object over here and extract out the key value pairs from this object, like as if it is a dictionary. So on top of that, you can see that OpenAI has also added additional methods and customized the behavior of this object so that it is more optimized for GPT-3's behavior. So for now, let's leave that. But what this means is we can extract out the text, which is the completion, from this response object, like as if it is a dictionary. So let's first get the choices from the key. So let's call this choices. And in this case, this choices key contains a list of dictionaries. I'll be taking the chance to import list, dictionary, and any. These are 3 type hints that we'll be using. This is a list of dictionary. And in this case, if we take a look at the dictionary's parameters, you can see that it is a mix of strings and integers, noun, values, and stuff. I'm going to give the key a type of string and the value to be a type of any. Any means is a super type that represents all types in Python. So I'll just be leaving that to any. And we can set choices to be equals to response choices. And once we're done, we get this list of dictionaries over here. But in this case, because we only have one completion, in this case, if you go under create, I guess it's better to go to the API reference. But because we didn't edit completions, n, where is the n over here? We didn't specify n, so n is defaulted to 1. So what this means is that you only have one completion here. So what this means is we can just get the first choice by getting the first element in this list over here. And we are guaranteed to only have one choice because we pass n to be equals to 1. So inside this dictionary, we can see that the completion is in text. So let's call this completion of type string, and let's access this at the text key over here. And let's try printing out this completion. Now I'll be running this script again to see if we were able to extract out the completion correctly from the OpenAI object. So looks okay, let's just wait for now. Okay, let's see. Okay, we got it. So we can see that we got the solution, and in this case interesting. They gave us a couple of solutions after that as well. This is quite dirty, but at least we were able to get the completion from the dictionary itself. But I guess this session gave us a little bit of hint of what we need to deal with. To be specific, we have to check whether if the completion is the actual completion that we want it to generate. We probably need to do some form of optimization. But for now, I guess that's it for this session. We explored how we can use the OpenAI library to get back a completion from the model, and how we were able to extract out the completion from a dictionary object that they give back to us. So with that, let me just wrap this up by adding this main file into Git status to check again. Let's commit this. So now, if we do git status, we can see that the file was committed. And if we check our git log now, we can see that we have source control both files thus far. So this will let our other software engineers see the evolution of this project. So that's pretty much it for this video. I hope this was useful to you to demonstrate to you how you should explore a given API that you have never seen before. Is this the best method? Definitely not, but I hope that this would give you some chance to see how a software engineer would explore this API. So with that, that's it for this video. I hope you enjoyed it, and we will see you in the next video.